Now let us solve this problem by using second derivative test, not first derivative test. By using second derivative test. So what is second derivative test? I already discussed the second derivative test in my previous video, but here let me explain the work rule or work steps. When you are given a function like this, let's say you are given a nonlinear function like this, and you want to calculate maximum point or y max equal to what at x equal to what. This is called maximum point. You want to know maximum point. Let's say the x coordinate a and y coordinate fa. This is the maximum point, and we want to calculate minimum point. Minimum point, which is, let's say, x coordinate b and y coordinate will be fb. And we will also calculate inflection point ip or sip. And we know the mathematical condition for maximum point is first derivative will be 0 and second derivative will be negative. For the minimum point, first derivative will be 0, second derivative will be positive. For the inflection point, first derivative is not important, but let me write here first derivative not 0, second derivative 0, and third derivative not 0. For the SIP, first derivative 0, second derivative also 0, and third derivative not 0. So the work steps in order to calculate maximum point, minimum point, inflection point, and a stationary inflection point. First you need to calculate first derivative of the given function, second derivative of the given function, and third derivative. If your question tells you to calculate SIP or IP, then you need to also calculate third derivative. And step 2, you will set first derivative equal to 0. To know the x values, or x coordinate, x values or x coordinate of the maximum point, minimum point, and stationary inflection point. By setting first derivative equal to 0, the x values you will obtain will be the x coordinate of either maximum point or minimum point or SIP or all of them. Number 3. Now, why it is called second derivative test? Because second derivative will confirm whether the point is a maximum point or minimum point or SIP or IP. So second derivative at, let's say, x equal to a, x values, for example, x equal to a, b, c, and so on. So you need to first check for x equal to a. If second derivative at a is negative, then there is a maximum point. If second derivative at a is positive, then there is a minimum point at x equal to a. If second derivative at a is 0, then you need to calculate third derivative at a. If not 0, then the point is a SIP. There is a SIP, stationary inflection point, at x equal to a. And number 4, for the inflection point, you need to set second derivative equal to 0 to know the x values or x coordinate of inflection point, to know the x coordinate of inflection point. So the x coordinate or inflection point we will get from the second derivative equal to 0. Second derivative will equal to 0 gives us the x coordinate of the IP, and let's say you will get x equal to d here. At x equal to d, if third derivative not 0, then you will confirm that there is a inflection point at x equal to d, and the y coordinate of inflection point you will obtain from the given function. If you put d in this function, in this given function, you will get y coordinate of all maximum point or minimum point or SIP or IP. If you put the x coordinate in the given function, you will get the y coordinate of the IP. So IP will be x coordinate is d, then y coordinate will be FD. Maximum point, if x coordinate is a, y coordinate will be FA. That you will get from the given function. Minimum point, let's say at B, then y coordinate will be FB. Inflection point, let's say at C, then y coordinate will be FC. So this is how you can solve any problem. These are the steps. Now let us solve this problem by using second derivative test. So you see, first we calculate first derivative. First derivative, how we calculate, you need to understand the previous chapter clearly to know how can we calculate first derivative. You see, derivative of x cube will be 3x square. So 3 and 3 will cancel. You will get x square. And derivative of x square is 2x. And derivative of minus 8x equal to 8. So this is the first derivative. And now you can calculate second derivative. If you differentiate first derivative again, you will get second derivative. So derivative of x square 2x, and derivative of 2x equal to 2. And again let us calculate third derivative, which is equal to, if you differentiate second derivative, you will get third derivative. Now by setting to know the location of stationary points, we need to put first derivative equal to 0. So x square plus 2x plus 8 equal to 0. By factoring, we can calculate the x values. There are two x values, x equal to 2 and x equal to minus 4. So the stationary points are at x equal to 2 and x equal to minus 4. These are the location of stationary points. These are the x coordinate of stationary points. Now the stationary points will be either maximum point or minimum point or stationary inflection point. Now let us check. Let us put x equal to 2 in the second derivative. We are not solving this problem by using first derivative test. So we don't need to follow these things. Since we are solving this problem by second derivative test, then our second steps will be what? We need to put x equal to 2 at second derivative. So x equal to 2 at second derivative will be what? This is the second derivative. 2 into 2 plus 2 equal to 6, which is positive. So there is a minimum point at x equal to 2. There is a minimum point at x equal to 2. And the y coordinate of minimum point you will get from the given function y mean. that is y mean, minimum value of y will be f2, which you will get from this function. If you put 2 here, you will get 2 cube by 3 plus 2 square, which is 4, minus 8 into 2, which is 16, plus 4. So this equal 8 by 3 minus 8, which is equal 8 minus 24 by 3, which is equal minus 16 by 3. So the minimum point is x coordinate 2 and y coordinate minus 16 by 3. These things we can write in this way. You see, y mean, minimum value of y equal minus 16 by 3 at x equal to 2. Now we need to do the same work for x equal to negative 4. It means we need to put negative 4 in the second derivative. F double prime negative 4 is equal 2 into negative 4 plus 2, which is equal negative 6, which is negative. So there is a maximum point at x equal to negative 4. And y coordinate of maximum point, or y max, maximum value of y equal to f negative 4. And f negative 4 means, from the given function, minus 4 whole cube by 3 plus minus 4 whole square, which is 16, plus, since minus 8 into minus 4, so it will be plus 32 plus 4, which is equal minus 64 by 3 plus, this is 4, so it will be 48, 52, 32 plus 16, 48 plus 4, 52. So LCM 3 minus 64 plus 6, 156. So 156 minus 64 will be what? Which is 92 by 3. So the maximum point is x coordinate negative 4, y coordinate 92 by 3. In other way, we can say y max, maximum value of y is equal 92 by 3 at x equal to negative 4. So there is no other x values, therefore there is no SIP, no stationary inflection point. So let me compare this result with the result what we did here by first derivative test. You see, the minimum point is this 2 minus 16 by 3. Our minimum point is this, and the maximum point is minus 4, 92 by 3, and there is no stationary inflection point, because by setting first derivative equal to 0, you obtain two x values, and at those x values, one is maximum point, another one is minimum point. So there is no SIP, but there is IP, inflection point. For the inflection point, we need to do what? For the inflection point, we need to set second derivative equal to 0. We need to set second derivative equal to 0. Let me write it again. 2x plus 2, and third derivative equal to 2. So for for IP inflection point, set second derivative of x equal to 0, and this implies 2x plus 2 equal to 0, and this implies x equal to -1. So there is a inflection point at x equal to -1 or not, we don't yet confirm. We need to check whether third derivative at -1 is not 0. Third derivative for any x equal to 2, so which is not 0. Therefore we now confirm that there is an IP, there is an inflection point at x equal to -1, and this is the x coordinate of IP. Now the y coordinate of inflection point will be f minus 1 from the given function. F minus 1 is equal -1 whole cube divided by 3 plus -1 whole square, -1 whole square minus 8 into -1 plus 4 this equal -1 whole cube, which is -1, because we know -1 to the power, if even then it is +1, and -1 to the power if odd number, then this is -1. So here -1 to the power odd number, therefore it is -1 by 3 plus -1 to the power even number, so this is 1 minus a plus 8 into 1 8 plus 4, this equal 13 minus 1 by 3, this equal 39 minus 1 by 3, this equal 38 by 3. So the inflection point is the coordinate of inflection point. Inflection point is x coordinate -1 and y coordinate 38 by 3. So the problem is now solved, but your question do not tell you, this question do not tells you to calculate IP. In addition, we calculate IP. If this is your question, then you just need to calculate max, mean and SIP, and you can say that there is no SIP. Okay, hope you understand the problem, and you can solve any problem using second derivative test. You don't need to know first derivative test. But in our next video, I will try to explain first derivative test later. But for now you don't need. You can solve any problem by using second derivative test. So you can check this one by yourself in your apartment. The result is this: there is a maximum point, there is a minimum point, and there is no SIP. You can also try this one in your apartment by using second derivative test. There is only one stationary point, x equal to 2, and at x equal to 2, second derivative will be 0. This is first derivative, so the second derivative will be what? 6x minus 12. Now if you put 2 in the second derivative, you see f double prime 2 is equal 12 minus 12, which is 0. So when second derivative equal to 0, you need third derivative. Third derivative of x equal to 6, and you need to put 2 in the third derivative. Third derivative of 2 will be also 6, since third derivative is always fixed, which is 6. So this is not 0, Therefore, now you can confirm that there is a SIP at x equal to 2, and the y coordinate of SIP you will get if you put x equal to 2 in the given function. If you put x equal to 2 in the given function, then you will get 5. You see, if you put x equal to 2 in the given function, you will get 5. So the coordinate of SIP is 2, 5, and there is no extremum point. It means there is no maximum point, no minimum point. And you can solve this one as well by yourself. For this one, there is no maximum or minimum point, only SIP. There is only one SIP, which is 1, 6. You can solve this one like before. And in this problem, you need to calculate all optimum points. Optimum points means maximum point as well as minimum point. Minimum point is called optimum point. And all inflection point, it means SIP and IP. SIP and IP, all inflection point, if has SIP, otherwise you will calculate only IP. So this is a 4th degree function, and you can solve this problem. In this handout I already solved this problem by second derivative test, so probably I don't need to explain. You can check it in your apartment. First you need to calculate first derivative, second derivative, third derivative, and by putting first derivative equal to 0, you will get 3x values. Now you need to check at these 3 values whether there is a maximum point or minimum point or SIP. First at 0, second derivative negative, so there is a maximum point, and the coordinate of maximum point is 0, 1. 1 you will get if you put 0 in the given function. Given function means this one. You need this function always to calculate the y coordinate. So we understand that there is a maximum point at x equal to 0. Now check at x equal to -1. At x equal to -1, second derivative is positive. So there is a minimum point at x equal to -1. And the y coordinate, if you put -1 in the given function, you will get y coordinate of the minimum point, which is -1, -10. Now for the third x value, 3 by 5. For the third x value, 3 by 5, again second derivative is positive. So there is another minimum value at x equal to 3 by 5. And the minimum point is this one. So sometimes you can see that a graph, there can be a graph like this, you see. So there are 2 minimum points, this one and this one. So between these 2 minimum points, this one is called absolute minimum point, because this one is the absolutely minimum. So here, which one is smaller y? Either this one or this one. Which one is smaller? I think -10 is smaller than this one. Therefore, this one is called absolute minimum point. But you don't need, since your question tells you to calculate extremum point, so you can say that there is one maximum point to minimum point, no problem. And there is no SIP, since there is no other x values. Now for the IP, you need to let second derivative equal to 0 and calculate x values. There are 2 x values, and at those x values, third derivative is not 0. You see, If you put x equal to minus 3 by 5 in the third derivative, it will be minus 168, which is not 0. And if you put 1 by 3 in the third derivative, it will be 168, which is not 0. So there are two IP inflection point. The y coordinate you will get similarly again from the given function. So 2IP will be, this one is the first inflection point and another inflection point is this one. So the result is that there are one maximum point, two minimum points and two inflection points. If you can understand this problem clearly, then you can solve any problem by yourself in this chapter. For example, let us have a look again in this solved problem. This one also I have solved here by second derivative test. Here you need to calculate optimum points and inflection points. It means max, mean and IP. So first you need to calculate first derivative, then second derivative, then third derivative, which is 6. And by putting first derivative equal to 0, you will get 2x values. It means there are two stationary points at x equal to 3 and 1. At x equal to 3, second derivative is positive, so there is a minimum point. The y coordinate you will get similarly from the given function. And at x equal to 1, second derivative is negative, so there is a maximum point at x equal to 1. The y coordinate you will get similarly again from the given function. This result we can write in another way. You see, y mean, we can say y mean equal to 1 at x equal to 3. And this one we can say y max, maximum value of y, which is 5 at x equal to 1. Now for the inflection point, we need to set second derivative equal to 0. That gives us x equal to 2. And at 2, third derivative is not 0. So there is a inflection point at 2 and y coordinate you will get from the given function, which is 2, 3. So the answer is there is one maximum point, one minimum point and one inflection point. Similarly, you can check this one in your apartment, and there are 4 other problems, real problems. Problem 1, 2, 3, 4 I will discuss in the next video. Thank you very much.